Hi, everyone. It's Amanda, and today I want to chat with you about whether your genes or mine or anybody else's play a role in blood pressure. In other words, are you predisposed to hypertension or elevated blood pressure now or in the future as a result of the genes you've inherited? And based on those same genes, are you salt sensitive or not salt sensitive? In other words, if you were hypertensive and you removed salt or significantly reduced the amount of salt in your diet, would that make a difference to your blood pressure? So it's a little bit of a conundrum. And it's a conundrum because research suggests that between 50 to 60% of individuals who are hypertensive or who do have elevated blood pressure, they're also salt sensitive. Now, some people could be salt sensitive, but they're normotensive. In other words, they may see a little bit of a blip in their blood pressure if they suddenly ate too much salt, but it's not long-term. They're normotensive. Salt is not playing a significant role for those individuals. Some individuals are hypertensive and yet salt resistant, or basically their elevated blood pressure has got nothing to do with the amount of salt they intake or don't. Salt is not a reason for their blood pressure to be elevated. So what's going on there? And the question is, how do you know who you are, which you are? And some of the answers can be found in your genes. So the genes we're going to look at briefly here are ACE, AGT, and NOS3. One of the things I want to let you know is I'm going to be talking very generally about these genes. But if we were to take the ACE gene, for example, the ACE gene has a number of different faces. That's the way I like to explain it. And those faces each have different identifiers. We call them an RS number. The RS number allows researchers and scientists, and even those of us who work in clinically, to know which aspect or which facet of the gene we're looking at. So that may sound a little bit confusing, but just know that each of these genes may have different variants or faces or identifiers that we look at to connect to the science. So let's start with our ACE gene. I've got my ACE playing card here. So the angiotensin converting enzyme, like the AGT gene that you're going to see, is important because it's integral to producing different proteins or components of the renin-angiotensin system that we also call RAS. And this is a system that we're most interested in because it regulates blood pressure. And one of the ways it does that is by helping the body balance total amount of fluids and salts. So you don't need too many, or don't need too much or too little. You need a balance. So the RAS system, the renin-angiotensin system, is integral to that balance. So looking at the ACE gene, the facet or the aspect of the ACE gene I want to show you in this presentation has to do with whether there is an insertion or a deletion. So what does this mean? So we know that we inherit one copy of a gene from our parents and one from our father and one from our mother. So you end up with kind of two alleles is what we call it, one from your mother and one from your father. So in the case of the ACE gene, and the one I'm showing you here, what we're looking at here is whether you have an insertion or a deletion. Did you inherit two insertions from your parents? So one from your father, one from your mother. Did you inherit a deletion? Did you inherit two deletion? Or did you inherit two insertions? Or did you inherit one of each? So what does all that mean? And what does this mean, insertion and deletion? It's kind of unique. So it means that specific to this gene, you inherited sort of an additional set of code or from the nucleotide, so the base information of the DNA. And if you inherited it, it's inserted. If it's missing, you didn't inherit it, it's deleted. So you could be a ACE, DD, deletion, mother and father, or you could be an ACE insertion, one copy from your mother, one from your father, or you could be ID or DI. So what does that even mean? Here's where it's kind of interesting. If you inherited an insertion, so from an I, from both your mother and your father, then you are salt sensitive. You're likely to be salt sensitive. So this means that your blood pressure is more likely to increase with a high salt intake. So guess what? If that's you, and you are sort of trending towards slightly higher blood pressure, one of the things you can do is lower the total amount of salt in your diet because you're sensitive to it. And if you're sensitive to it and you reduce the total amount of salt, then you're more likely to see some responsiveness. Now, of course, salt isn't the only thing that plays into blood pressure. If you're not exercising enough, if you're having some challenges managing your weight, if you stress, all of these aspects can play into your blood pressure. So don't just pin everything on salt, but know if you're ACE-II, you could be better served by monitoring the total amount of salt in your diet. Now, if you're ACE-DD, here's some caveats for you, and this is where genetics gets to be quite complex, which is why we always work with clinicians to help you navigate what is your blueprint, who are you? So if you're an ACE-DD, deletion, your blood pressure may be less salt sensitive. So if you are hypertensive, you do walk around with elevated blood pressure, reducing the total amount of salt in your diet may not be as impactful as if you had the II variants. In other words, salt may impact you, but far less noticeable if that was the only thing you're changing your diet than if you were the II. So it's different. You say, okay, well, great. So what would I do? Exercise, monitor what you're eating, monitor how much fat you're taking in. And the DD genotype is very responsive to changing up your fat to include more EPA and DHA, which are omega-3 fats. Now, listen, we all need to include omega-3 fatty acids, but some of us, depending on our total gene blueprint, can actually be more receptive or more responsive to these little changes, in this case, in our fat content, to help kind of smooth over some of those variants we have in our genes. So DD variants, summarizing, you may not be as responsive to changes in salt than as somebody who has an II variant. You also, depending on what your total gene blueprint looks like, may be predisposed to hypertension or a higher risk for heart disease, regardless of salt. So other factors come into play if you're a DD. You're not kind of scot-free. None of us are. But salt reduction is not probably the first priority for you if you are hypertensive. Gets confusing, doesn't it? But again, this is where we kind of fiddle. Those of us who work in genetics, we fiddle in the bottom of these buckets and try and put together the patterns for you. What about the angiotensin gene? So again, like the ACE gene, it's involved in this renin-angiotensin system, which helps to regulate blood pressure. So what we do know is that elevated levels of angiotensin are associated with higher blood pressure, and they're also associated, if you are walking around normotensive, they are associated with a higher susceptibility as time goes on to hypertension and cardiovascular disease. So again, it's just something you put in the back of your mind. One thing that's important about genetics is just because your genes suggest something doesn't mean to say it's so. There's signposts that we look at to ask questions and check things out. So what do we look at when we're looking at AGT? Here, we're looking at these specific variants, A and G. So remember with the ACE gene, we looked at I and D, insertion deletion. Here we're looking at A and D. So this means you could have any combination of these, AA, GG, GA, for example. What we then do is say, okay, which ones do we need to pay attention to and why? So you and your AGT gene, this is where it's really interesting. What we know from research is that if you are the AA genotype, so you're AGT, AA is what comes out in your report, and you are hypertensive, then you are far more likely to see a reduction in your blood pressure if you reduce your salt intake. Concurrently, if you are carrying extra weight and you know you need to shift that, reducing your weight along with your salt intake is going to help you far more rapidly return to sort of a more normal blood pressure than if you had a different genotype. And this is evidence from the research that says that after 8 weeks, the total, so the net systolic and diastolic blood pressure response to the NASH diet was significantly greatest in individuals with the AA genotype versus the GG genotype. And this, I'm not actually showing the citation here on the slide, but this is research. It took place in 2001 and appeared in Hypertension magazine. And I've seen this research repeated year after year after year. It's a really landmark study when you're looking at the impact of genes and blood pressure. So the AA genotype is responsive to salt, whereas the GG genotype, not so much so. So we saw that already with the ACE gene. It really depends on your genotype. And to that point, the GG genotype is more prone to those higher angiotensin levels. Higher levels of angiotensin are associated with a higher proclivity or propensity towards higher blood pressure if you don't kind of exercise and, you know, keep stress under control, etc. So what's interesting is, and here's the caveat here, the GG genotype is actually more salt sensitive in general, but when it comes to hypertension and blood pressure, you're less responsive. So, you know, you can see other systems or other reactivities if you have a very high salt diet. High salt diets are also associated with predisposition to heart disease, cardiometabolic related issues outside of hypertension. So if you wonder, well, what does this mean? So the GG genotype can actually be more sensitive than the AA genotype, but if you're trying to control your blood pressure by reducing salt, don't see the same level as responsiveness than if you were the AA genotype. So what do? Watch what you eat. Eat the healthy fats. Don't eat too much. Watch your stress levels and make sure you're moving in a way that works for you and is healthy for you. Final gene, the NAS3 gene. So this stands for nitric oxide synthase. So the NAS3 gene encodes the enzyme that helps your body produce nitric oxide. Nitric oxide has a number of different roles, but specifically when we're looking at your blood pressure, nitric oxide helps to dilate or expand your blood vessels. Pretty important, right? Because constricted or stiff or very narrow blood vessels are associated with higher blood pressure. So we want nice, supple, dilated, not floppy, but dilated blood vessels. What do we know about the genotypes or these variants associated with NAS3 that could indicate potential predisposition to hypertension or higher blood pressure risk? So you heard me talk about II and DD. We just talked about GG and AA. Don't you love this nomenclature? So with NAS3, the genotypes are associated with reduced nitric oxide production and therefore higher blood pressure risk are GT and TT. So what do you do if you're a GT and TT? Well, you know, it's as usual, right? We want to make sure that you're moving, that you're maintaining weight that's healthy for you, that you're eating a wide variety of fruits and vegetables. But the other thing I want to share with you is you want to help your body produce its own nitric oxide. And to do that, it needs basically the foundation nutrients. And one of the most important ones to get through food is arginine. Now, arginine you find in animal proteins. So if you're eating animal proteins, the chances are you're getting arginine, but you don't just want a diet that's based on animal protein, right? And if you don't eat animal proteins, what would you eat? So here's where you want to go into your nuts and seeds. So what I've listed here are really, really good sources of arginine. And when they come in plants like nuts and seeds, they come with a healthy dose of vitamins and minerals too, such as zinc and manganese and magnesium. So look to your pumpkin seeds and things like your butternut squash seeds, sunflower sesame seeds, hemp seeds, but also your nuts, peanuts, almonds, hazelnuts, for example. And I put soybeans in there as well. So give your body the information it needs. If you're somebody who is already walking around with higher blood pressure and you're trying to manage it, think about how your body produces this basic information to help you reduce your blood pressure. So arginine in food, please not as a supplement unless you're supervised, is really, really important. And I will say it's very important if you are taking arginine that it is supervised, because nitric oxide is really, really important to the body. But if you overproduce it and you're in a status of what we call a state of oxidative stress, where there's a lot of inflammation in your body, it actually can be quite damaging to you. It'll produce a very toxic free radical that you don't want. So I do not recommend arginine as a supplement unless you know what you're doing and you are being supervised, and understand that. I cannot emphasize that enough. So one of the questions that comes up then is, well, can't we just eat beets or cured meat? Aren't they a great source of nitrates? Well, we're going to put meat aside, but one of the things that's very popular with athletes are beets, because they can act as sort of a juggernaut to provide dietary nitrate or nitrate sources that can be converted to nitric oxide. A couple of things here is that nitric oxide has to be produced all the time. You want it to be produced all the time because it has a half-life of about 1 millisecond. So it doesn't last very long. That's why it's sort of a really great chug after sort of a really hard ride or athletic performance. But it doesn't stick around very long. So you want to make sure you have a consistent source of information for your body to produce its own nitric oxide. And that is by providing the basic information, which is through arginine, and now you know where to find arginine. So you want to keep pushing the basic food information, or as we call it, substrates, into your body so that you can always produce nitric oxide, not just wait for a chug or something. So definitely beets have a role, and fruit and vegetables are a great source of these substrates for to produce nitric oxide. But if you're not eating lots of fruits and vegetables or nuts and seeds, you're missing out on the opportunity to produce your own sort of lower blood pressure soothing or lowering information. So hopefully what you've seen here is a quick tour through genes, some of the genes that we know that can impact your blood pressure. Important final note, just because your gene or your gene information suggests that, my gosh, I got an II and an AA and what have you, just because it suggests a higher potential for, in this case, a higher blood pressure, does not mean to say it's so. Genes are not diagnostic. They're not predictive. They're what we say clinically. They're signposts that tell us where to look, questions to ask, things to investigate, to validate, yep, you need to make some changes, or hey, you're good to go. But, check in, every 6 months, every year with your blood pressure in this case, and make sure you're on track. All righty, so ACE, AGT, NOS3, and now you know a little bit more about your genes, your blood pressure, and whether salt is relevant to you or not. Thanks so much, everyone.